Algebra 2, Section 1-2 notes, equations. One of the things that you'll notice with this section in Chapter 1 is that there's not a ton of focus on the process of solving equations, but just understanding what they are and how to compare them and how to determine if something is a solution to an equation without necessarily going through the process of solving. So the first page we have, it says, this is the first part of the section in the book, an equation, and we know that that's obviously going to be the key here, is a statement that two expressions are equal. So it's got to be two separate expressions, and they're going to be equal. They often arise when we want to find a value of a variable that makes two different expressions equal to one another. So finding the value of the variable is what we're trying to do. A value of the variable that makes the expressions on either side of an equation equal to each other is called a solution of the equation. So all terms that we should be familiar with so far. A solution makes the equation, and I stressed this last year in Algebra 1, it makes it a true statement. So true statement. Those are all terms that we'll be using all year. All right, so let's slide over to the second slide just so you can get the idea of what they're looking for here. It says you have a $10 discount certificate for a pair of pants. When you go to the store, you discover that there's a 25% off sale on all pants, but no further discounts apply. For what tag price do you end up paying the same amount with each discount method? And what they want you to do here is obviously come up with the equation first. That's going to be the challenging part for you. So it says you have a $10 discount certificate for a pair of pants. So we're going to call P, that's going to be our variable for the pair of pants. So in one situation, we have a $10 discount certificate on the pair of pants. So that's going to be P minus 10. That's what you would pay for total price. The other situation, when you get to the store, you discover there's a 25% off sale on all pants, but you can't use any further discounts. So you can't use that certificate for this one. So the other side of my equation, since it's 25% off, I know that I would pay 75% for the pair of pants, so 75% of the original price. Now, if you look in the textbook, instead of solving this, what they want you to do is to plug some values in and make a table. And we talked a lot about, in Algebra 1, about making tables to see what values would work, and also choosing smart values for your table. So if the tag price of the pair of pants is a particular amount, how can we compare that to $10 off and 75% off the original price? So they just pick some values here. They start with $20. So if the pants were $20, $10 off would be 10, and 75% would be $15. Then they jump up to 30, and if the pants are $30, $10 off would be $20, and 75% would be $22.50. So what we want to notice, and they want you to really think about this as you're plugging values in, is that the difference between these two values is now smaller, so we know we're moving in the right direction for the price of the pair of pants. If we go to $40, $10 off of that is 30, and 75% of that is also 30. Had we kept plugging values in, they would have started to get further and further away from each other, with the discount certificate now being the greater price. But $40 is our answer for this one. And notice we didn't go about solving it, we just plugged values in, which if it was an uglier number other than a multiple of 10, wouldn't be the most efficient way to do that. Okay, so let's slide down now to the third slide. It says for each of the following equations, which of the given values is a solution? So now, similar to what we did with expressions, you're just going to plug these values in. So if we take a look at the first one, -3, this would give me 3 minus, and when I plug -3 in there, that's -12. So that side's going to be 15. And when I plug it in on this side, it'll give me 5 minus, and if I do 2 plus -3, that's going to give me -1 in here, so that's 6, so -3 is not a solution. If I plug 0 in, this side right here will give me 3 minus 0, which is 3, and then in this side, draw a line right there, 5 minus 2 plus 0, so that'd be 5 minus 2 is also equal to 3, so we know 0 is a solution. So similar to plugging values in, just want you to see what works. All right, so go ahead and take a minute and work on B on your own. Okay, so if you plugged all 3 of these in, you should have noticed that both -1 and 1 work, and that's because we're squaring that value. So if we just look at -1 and you plug that in, you get 3 times 1 plus 5, which is 3 plus 5, which equals 8. So that works. Then if you plug 1 in, that will also work. So in this particular situation, 2 of the answers work, but 0 does not work. If you plug that in, this side right here would still be 5 if you plugged 0 in. Okay, sliding on then to example 3. It says you have $10 to spend on N bottles of soda costing $1.50 each. So 2 things that they want you to do. They want you to determine if the following are expressions or equations, and then give an interpretation. This is going to be a big part of what this textbook asks you to do, is to give a literal or practical interpretation. So $1.50 N right here is going to be an expression. We'll abbreviate that. And $1.50 N would be the price of purchasing N bottles of soda. And I'm not going to write all that. You can just follow along and jot that down if you want to. All right, B is an equation. There's an equal sign. It's comparing 2 expressions. And that situation would be the number of bottles you could buy and spending a total of $6. Okay, moving on to example C. This is an expression once again, and what this expression means is we know that it's $1.50 per bottle. This is saying that you have $10 to start with. So what this means is that this is the money remaining after you buy N bottles of soda. All right, and the last one here is an equation, and it's similar to C, that it's the money remaining, but now they give you a specific amount, saying that your total that you're left with is $2.50. All right, example 4, it says find all the solutions to the following equations. So on the other pages, we use sort of a trial and error method, or you plug values in. These are all going to be one-step operations, and we're not even talking about what the process is to solve, but just by looking at them and solving. So this should be pretty straightforward. So if x plus 5 equals 17, we know then that x has to equal 12, and that's all they're asking you to do here. This equation here, 20 equals 4 times a, so a would have to equal 5. This one here, and again they're using the / as division, so s divided by 3 is 22. We know that s is going to equal 66, and that's the only solution. And then here we can see that g squared is 9, and because the variable is being squared, we know that there are going to be 2 possible values, so g could equal either 7 or -7. Again, just trying to introduce you again to the idea of equations and what it means to solve them. So pretty straightforward examples there. Now, this is another thing they want you to think through this instead of just diving right into the process of solving. Look at what the directions say for these examples. Find solutions by looking for structure in the equations. All right? So what they're saying is that if you have a division problem like this that ends up equaling 1, you know that this fraction here has to have a numerator and denominator that are equal. So if x plus 1 has to equal 5, that means that 4 is the only solution that we could get for this one. So notice we didn't go through the process of solving, we just talked about looking at the structure of the problem. B is very similar. If a fraction ends up equaling 0, that means that the numerator has to equal 0. So the only answer that will work for this one is x is equal to 7. Looking at example 5c, we can see that the left side and the right side are just opposites of one another. So we have 9 minus z is equal to z minus 9. And since they're equal to opposites, or the textbook says it's the negative of the left side's the negative of the right side, we are looking for a number who is equal to its opposite. And since the only number that's equal to its opposite is 0, we have to figure out a value of z that we could plug in that would make both of these sides 0. Therefore, the only thing that's going to work here is if z is equal to 9. So again, we looked at the structure, the two sides were opposites, so z has to be 9 to make it 0 equal to 0. All right, example 5d, if you look at it, it says the constants multiplying the powers of x on the left side all add up to 0. So the constant here is 1, negative 5, 5, negative 1. So these two would cancel out, those two would cancel out. But that's only going to work if t was equal to 1. Because if you do 1 to the third, 1 to the second, or 1 to the first, or just t, that's not going to change the value of the constant. So if t is equal to 1, what that would do is that would make this right here equal to 1, this equal to negative 5, that equal to 5, and that equal to negative 1. So that structure is a little harder to catch, and we know that there are other ways to solve these, but for this particular problem, they just wanted you to look at the structure and see if you could figure that out. Example 6, it says for each of the following equations, why is there no solution? Again, I'm probably not going to write a whole lot. I'll just sort of underline stuff and explain it. So if you look at A, it says x squared is equal to negative 4. And hopefully you can see that it's not going to work because anytime you square a number, there's no way to get a negative quantity based on what we know right now. All right, so that one can't work. It's either going to be 0 or positive. B, if you have t and then you add 1 to t, there's no way that that can be equal because t equals t is an identity, and if you add 1 to this side, that means that this side's going to be larger than the left side, so that's not going to work. C, if you take a look at this one, we know, and we talked about this on the previous slide, that if you have a fraction that equals 1, your numerator and your denominator have to be equivalent. And again, if you set that up as an equation because you wanted those to be equivalent, you can see that this would be an identity if it was 3x plus 1 and 3x plus 1, but it's not. Since these two values are different, that's not going to equal it. All right, so that can't work. All right, and this last one, D, there's no solution because we're taking the square root. If you take the square root of a quantity, you're not going to be able to end up with a negative value. That's not going to work, so that's why that one doesn't have a solution either. Example 7, let's take a look. It says you will receive a C in a course if your average on 4 tests is between a 70 and a 79. Suppose you scored a 50, 78, and 84 on the first 3 tests. Write an equation that allows you to determine the lowest score you need on the 4th test to receive a C. What is the lowest score? All right, I want you to go ahead and pause this and try to come up with the equation on your own, then check it with mine, and then we can solve together. Okay, so hopefully you've written your own equation. You have 3 tests that you've already earned a 50, a 78, and an 84 on. And they want to know what's the lowest score you need on the 4th test to receive a C for the quarter or for the course. So that 4th test we're going to call G for the grade that you need on it. And to find an average, we know that we are going to divide that by how many scores there are, which is 4. And we want that to equal, and because it says the lowest score, we can get an absolute minimum of 70, right? And that will give us a C. So that should be your equation. And if you add these up, you get 212 plus g over 4.